So this is an activity where we're going to investigate the effects of numbers on a graph, and like if numbers are out front, what they're going to do to it, if they're inside like the absolute value bars, or if they're outside the absolute value bars. So the first thing we're going to look at is we're looking at the absolute value of x. And the first thing it wants us to do is to graph the absolute value of x in our coordinate plane. And I'm just going to do it in black. And I'm going to make this a little bit bigger here. So when we graph it, we just have here, and it is a V shape. Okay, so this is called the parent function. And what you're going to do is we compare all graphs to the parent function. And we want to leave this on our graph so it's easy to compare it to. And then what we're going to do is we're going to graph the actual function. So like for part 1 here, we're going to graph 3 times the absolute value of x. So if we do 3 times the absolute value of x, if we just create a table over here to the side, so if we have 3 absolute value of x, we have our x value and we have our y value. Of course, if we plug in 0, we have 3 times the absolute value of 0. Of course, the absolute value is 0, and 3 times 0 is 0. So our first point would just be 0, 0, 0. All right, and then if we do 1, 3 times the absolute value of 1, well, absolute value of 1 is 1, 3 times 1 is 3. So then the coordinates for this one are 1, 3. Okay, and then if we do -1, we have 3 times the absolute value of -1. So remember, absolute value of a number is just the positive. So it's 3 times 1, which will be 3. So our coordinate here is also, or it's going to be -1, positive 3. So it's going to be here. So this graph, if you notice, is going to be more narrow. So our vertex stayed the same. The slope of the sides, so if you remember slope of sides, and this goes back to math 1. It's been a while since you've done slope, but remember slope is rise over run. But if you count how far up, so if we just count here, so if we start at the origin and we go up 1, 2, 3, and over 1. So our slope is going to be 3. And how did the graph change from f of x from our original graph? So what we would say is multiplying by a number greater than 1 stretches the graph. So it's actually going to make it look skinnier. Okay, so that's what the graph is going to do. Okay, so now let's look and see what happens when we multiply by a third, so something less than 1, okay? So the same thing. If let's plot our points here. So here's my original graph, okay? And then if we do our points, 1/3 times x. So of course if I do 0, 1/3 times absolute value of 0 is just going to be 0. And if we do 1, we have 1/3 times absolute value of 1. Well, that's just going to be 1/3. So my coordinate is going to be 1 and 1/3. So I go over 1 and up 1/3. So that's just barely up any, especially on our small graph here. And if we do -1, we get, that's supposed to be absolute value. Of course, that's going to turn into a +1. +1 times 1/3 will be 1/3. So then our coordinates would be -1, 1/3. So on the same side over there. So this graph is going to look more like this. So our vertex still stayed at 0, 0. Slope of the sides, this time we went up 1/3 and over 1. So our slope is 1/3. And so we would say multiplying by a number between 0 and 1 compresses the graph. And so it's going to make it look wider. It's going to make it look fatter, however you want to think about that. Okay, so now let's look and see what a negative is going to do. Okay, so if we plot our original graph here, okay, and if we set up our table, oops, I'm just thinking of my last problem. So now I have negative absolute value of x and y. So if I plug in 0, of course you can't make 0, 0, so that's just going to be 0, 0. So my vertex is still going to be 0, 0. But if I do -1, absolute value of -1 is just 1, but then I have this negative here on the outside. So my y value is -1. So my coordinates are now -1, -1. And then if we do a +1, absolute value of 1 is 1, but I still have a negative. So I have 1, -1. Okay, so my slope is going to be going down. It's going to be -1. And what's changing is it is flipped across the x-axis. Okay. Okay, so moving on. Let's make our following conclusions. So if the absolute value of a is greater than 1, the graph narrows, and this is called a stretch. If a, so like your number out in front of the graph, if it's between 0 and 1, the graph widens. And this is actually called a compression. And if a is negative, so if you got a negative out front, the graph reflects across the x-axis. Okay, so now let's look at the effect of h. So in our general form up here, so this is what we're referring to. Here is h. Notice h is on the inside. So let's look and see what the inside is doing. Okay, so if I do my basic graph here, okay, so if I do my table, okay, so if we do 0, absolute value of 0 plus 3 is going to be 3. So now my new vertex is at 0, 3. Sorry, that's not my vertex. Okay, so there's that point. All right, if I do a -1, I've got -1 plus 3, so that's going to give me 2. So then I've got -1, 2. That puts me right there. And what I can also do, because I can see that this graph, I can see that it's going down here, okay? So I know that it's been shifted. And so what we can do here is we can also use Desmos to help us out a little bit as well. So if we go to Desmos and if we type in our graph, if we do our absolute value of x plus 3, and we click on our point here, we've got negative 3, 0. There's your vertex. So your vertex is at negative 3, 0. Okay? My slope and my sides are still 1. Okay? So even if we look here, you know, notice that if we just focus here, it's just going up 1 over 1 every single time on the graph. Okay? So how did the graph change from the original graph? So if I plot this here, there was my vertex, okay? And so notice it went to the left. It shifted left 3 units, okay? So it shifted left 3 units. So notice, just kind of notice what's going on here. It was a plus 3. And it shifted left 3 units, okay? So keep that in mind as we do the next one here, okay? So if we look at number 6, if we go to Desmos for it, we have this absolute value of x minus 5, okay? So its vertex, if we click on it, is at 5, 0. Okay, so its vertex 1, 2, 3, 4, 5 is at 5, 0. Okay, so there's that. My slope hasn't changed. My slope is still at 1. Okay, because if I go back and look here, notice it's still like on, you know, I'm still going up 1 over 1 every time. Okay, so I'm still at, like, here would be at the x and y values. Notice they're exactly the same. Okay, or not exactly the same, sorry, but it's still going, like it's still, you know, I'm at 6, 1 right here, okay, and then I would go up 1 over 1, up 1 over 1, so my slope is still 1. Okay, so how did the graph change? So from here, if I, you know, have my original graph, we went to the right, so it shifted right 5 units, okay? So notice this was a minus 5, but it went right, okay? So what's our conclusion here? If the sign inside the absolute value bars is a plus, the graph moves left. If the side inside the absolute values is a minus, the graph moves right. So it kind of does like opposite of what I think it would do. Most of the time if I think plus, I'm thinking, you know, the positive side of the graph, but inside it's going to do opposite. Okay, so now let's look at the effect on K. And if I go back up here, if we look at K, you know, K is right here. K is on the outside. So let's see what the effects of K are doing. So if you just think a second, if inside moves right and left, outside, what direction do you think it's going to move? Okay, so if we look at the absolute value of x plus 8, oops. So here's my original graph, okay? So if we use Desmos to help us out, we got the absolute value of x plus 8. So notice where your vertex has moved to now. Now my vertex is at 0, 8, so it moved up. So now my vertex is at 0, 8. And how did the graph change? It shifted up 8 units. Okay, so if we plot this one, okay. All right, and for this one, what do you think your vertex would be without even graphing it? Hopefully you're saying your vertex is going to be at 0, negative 6. So it's going to be down here. Okay, and if we want to look at Desmos just to verify it, So if you do -6, and it did, in fact, move down. So there's your vertex at -6. Okay, so it shifted down 6 units. Okay, and so how can you use H and K to determine the vertex of V? So we would say H is the X, and we also have to think of it as like being the opposite. And K is the Y. So it's like we're doing, as far as X, Y, that's your coordinate for that. Okay, so do this without a calculator or, in our case, do it without Desmos. Try to do it without Desmos, but you can use it to verify. So try to do it without Desmos first, and then you would verify. So pause the video and see if you can figure out these moves on your own, and then you can watch the video or use Desmos to verify it, okay? All right, so on these, this would be shifted up 5 units. Number 2, with the +2 on the inside, shifted left 2 units. With the -9 on the inside, shifted right 9 units. All right, we got a -4 on the outside, so it's flipped across the x-axis, and it is stretched by a factor of 4. Okay, so two different things going on there. All right, number 5 is shifted down 3 units. Number 6 is compressed by a factor of 1/3. Number 7, we got 2 things going on. You got the +2 on the inside, so it is shifted left 2 units. And then the -3 on the outside and down 3 units. Okay. Number 8, the 2 out front, stretched by a factor of 2. And then the -4 on the inside is going to be right 4 units. And number 9, we got a lot going on this one. So it is reflected across the x-axis. It is compressed by a factor of 1/2. And the +1 here on the end means it's going up 1 unit. Okay. So now let's write our own equation, okay? So up 7 and left 3. So we have y equals absolute value of x. Left 3 is going to be inside, so +3, and then +7 on the outside, up 7. Okay, 11. Reflects means we're going to have a negative. Vertical shrink of 1/3, we're going to have the 1/3 there. So I've done this, and then down 2. So nothing on the inside because right and left is only on the inside, and then down 2. Okay, vertical stretch of 2, that's going to go out front, and then right 6, so that's going to be -6 on the inside. So remember, inside is going to be right and left. So if you want to think of it like this, out front is going to be a stretch or compression. Okay, then you've got your absolute value, which is going to be right or left. And then on the end is going to be up or down. Okay, right is going to be a minus, left is going to be plus, up will be plus, down will be minus. So maybe that'll help you out a little bit. And then, of course, a negative, you'll have a negative out front if it is reflected. Okay. So, if we look at this, we got vertex is 4, -3, and goes through 6, 9. Okay, so if our vertex is at 4, 3, and it goes through 6, 9, then the way that we do this, the first thing that we would do is, remember we said that we can use the vertex to help us get H and K, okay? So we have X minus 4, because that was the opposite for X, and then minus 3. And then what we use is we use the points to get our slope, which is our stretch, okay? So we're going to take and find our slope between our points. So we do our y's over run, or like your y, subtract your y's over x's. So you're going to do -3 minus -9 from here and here. That's on top. And then you'll do 4 minus 6 from here and here on the bottom. Okay? And then that's going to give us 6 over -2, which gives us -3. And so that's going to be your number that you know goes out front. So that's how you use this point to help get your equation. So your vertex you use for H and K for here and here. And then if they give you another point, you use that to help find like your stretch or compression if it's reflected across the x-axis. Okay? So 14, it gives us a picture of a graph. So if you look, your vertex is right here at 3, 1. So we can fill part of it in. So we have x minus 3. Remember, it's the opposite. And then plus 1. And then if we figure out what our slope is, I'm just going to count my slope. I went up 1 and over 1, 2. So up 1 over 2. So it is going to be a half. And I know it's not reflected because I know it's my V is pointing up. So I know it's just a positive there. Okay. So how is f of x equals x minus 4 shifted from x plus 3 minus 1? Okay. So if you look at the difference here, compare minus 4 to plus 3. So you were down 4 and, you were, think of the minus 4 as that you were right 4, and now you're left 3. So we moved 7 to the left. Because if you think about this being on a number line, okay, we were right 1, 2, 3, 4, if I'm just thinking about being right here. And then I ended up being over here. So we went 1, 2, 3, 4, 5, 6, 7. I went this direction. I went to the left 7 units. And then I just basically went down 1 because there was nothing on the outside here, and I went down 1. Okay? Okay, so then from the next one, how is g of x equals 1/3 absolute value of x plus 3 plus 1 transformed from to absolute value of x minus 4 minus 5? Okay, so for this one, how is it transformed from this one? So if we start with this one right here, so if I go from 2 to 1/3, 2 was skinnier, 1/3 is going to be wider. So it became wider because I went from 2 to 1/3. Okay, if we think about this being on a number line, if we were at -4, so that means I actually started out right 4, 1, 2, 3, 4. If we think of it like that, and then I went to the left 3, 1, 2, 3. Same thing here. I went to the right 1, 2, 3, 4, 5, 6, 7. Okay, moved 7 to the left. And then I was down 5. 1, 2, 3, 4, 5. I was down here. And now I'm up 1. So I would move 1, 2, 3, 4, 5, 6. So it moved up 6. Okay. So consider the parent function y equals x squared. So where will the vertex of y equals x minus 3 squared plus 4 be? So it's very, very similar to the absolute value, okay? We're still looking at these numbers as h and k. So it would be positive 3, positive 4. Where would the vertex of y equals x plus 3 squared minus 5 be? Same thing. You're going to do negative 3, negative 5. Remember, if it's on the inside, you take the opposite. Okay. On 19, sketch the graph of y equals x minus 2 squared plus 1. So our vertex is going to be at 2, 1. So here's my vertex. And remember, this is a parabola. Okay. So this is a parabola. All right, write the equation of the parabola that has a vertex of negative 2, 3. So, whoops, forgot my y equals x plus 2 squared plus 3, because you want to do the opposite for your x. All right, what is the equation of this one? So my vertex here is negative 1, positive 2. So I've got y equals x plus 1 squared plus 2. Now, this one has been flipped, so I would put a negative on the outside. So this has been flipped upside down. All right, now let's consider the parent function, the square root of x. How is this shifted? So same thing. If it's on the inside, you're going right and left. If it's on the outside, you're going up and down. So this one would be shifted left 3, down 2. All right, for 23, give the equation of this one. So if you look here, this is at negative 2, 0. So this has been moved to the left 2. So you would do y equals the square root of x plus 2. Remember, left gets a plus. And then if you were given the graph of f of x, how would f of x minus 3 plus 2 be shifted? So that would just be shift right 3 up 2. Remember, minus means you go to the right because it's on the inside, and that plus 2 is on the outside, so it would be up 2.